All right, you guys, good evening. It's Dr. Green. I wanted to go ahead and record this lecture for you guys. Really appreciate you guys' patience over the past week. Things have just had a lot going on personally um, between various obligations and also personal factors, but wanted to post a lecture. This is the last lecture for this section of the course before exam one. I will have your review coming hopefully tomorrow night or Sunday. We'll have that posted for you. That way you know everything that you need to know for the exam. So let me share my screen and we will get rolling. It should be pretty short and sweet. All right. So I am not going to obviously maximize this because for some reason I tend to lose my screen when I maximize. I'm not really sure what's up with that. Yep. Okay. So, okay, guys. So we've been talking about validity. We talked a lot about internal validity, but now we're going to kind of shift to external validity and replication. So we've already talked about that. There's essentially a balance in a relationship, right, between internal validity and external validity, right? So internal validity referring to the pureness of the methods inside of our study, right? And based on the pureness of those methods, that allows us to essentially establish, can we truly say that the independent variable is what's causing the effect on the dependent variable, right? So external validity asks a different question. It asks the question, how certain can we be that our results are generalizable to the outside world, right? How applicable are our findings? Okay, so as we just said, we want to try to determine the extent to which our findings are generalizable to the population as a whole, because generally in research we study samples, but the goal always, right, is to take those results and generalize them to the population as a whole. So that term, right, that ability to generalize, okay, that's called ecological validity, right? So ecological validity means, is it measuring what it's supposed to measure in the environment, right? So ultimately, if the results of a study generalize to the population in a high manner, right, and we're able to take that study and produce it again and again and again, and get the same results, right, in different populations and settings, then it has high external validity, right? Now, here's the thing. Generally speaking, when we talk about experimental designs, external validity can be a lot harder to achieve, right? Because a lot of those experimental studies take place in laboratory environments that don't have relevance to the population as a whole, right? And also, one of the things that we often see is when we have experimental studies that take place because of ethical concerns and applying those studies on humans, generally speaking, primarily, these are applied on animals first. And so clearly, results or studies conducted on animals generally are not applicable to humans. And so that kind of sheds light on yet another issue with external validity. Okay, so here's the deal, right? Ultimately, the end goal, right? If we have a study that has a high level of external validity, generalizability, ecological validity, right? We should be able to take that study and apply that in different environments, and we should get the same thing every time. Okay, so ultimately, the higher that the replicability is, the more often and the more frequency. Sorry, words are hard. The more frequency with which a study can be replicated, right? The more generalizable it is, and the more external validity it has. So clearly, right? In a perfect world, okay, internal and external validity would be balanced, right? So the study would have high levels of internal validity and it would be generalizable, and that would be fantastic, right? But often that's not how the world works, right? So when we talk about replication, there are two main types of replication. Okay, the first type being direct replication. And I'm going to show you guys an example of this in a minute. So the key question here, does the study produce the same results from a different data set that use the same methods? So, for example, if we take a study that was conducted, we read that study in a journal, and we want to determine is this replicable, we would take the exact same methodology, recruit similar participants that had similar characteristics to the study that was previously conducted, use the exact same results, but remember, a new population, okay, a new sample, and new methods will always produce a new data set, right? It's a brand new set of data, okay? And so because we have a brand new set of data, okay, ultimately the goal and the hope is that that new set of data will match the pre-existing set of data that we're pulling from the other study. If it does, then that study displays a high level of direct replication. Conceptual replication is a little different though, because, right, with conceptual replication, we are attempting to replicate a concept. Now, we may take that concept and we may apply different, participants, methods, settings, right, and a different design to a concept, okay? But as long as we are still, testing the same general concept, right, as the outcome, right, we can essentially manipulate the variables and change the participants, the settings, and how we collect the data, right, as far as a design. Now, and we'll talk about this here in just a second, but this is also obviously very important for observational studies as well. Okay, so what's an example of this? Okay, first and foremost at the top, okay, we have direct replication. So we have a non-changing element, so we start on the left side. Okay, we see subjects, design, and methods. Remember, like we talked about, we're using the exact same study design and trying to replicate it. Okay, now here's the thing. Always, 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 when we have a new set of research subjects, and methods and design, even though those are the same, that experiment that is replicated always results in a new data set, right? Because it's a new experiment. Okay, now we then analyze that data, and then that, okay, is an example of direct replication. Sorry for the typo there. There's change is not spelled correctly. But, okay, once again, subjects, methods, design don't change. Okay, we do it again. It produces a new data set. We analyze the data. That is an example of direct replication. Okay, conversely, if we look, for example, at conceptual replication, the elements that we have the freedom to change in conceptual replication is the subjects, right? So who we recruit for the study, the methodology, right? Exactly how we, inclusion, exclusion criteria, so on and so forth, how we design the study, how many groups, whether we stratify or don't stratify, right? We can do whatever, right? As long as we're testing the same concept. Okay, now, obviously, as we know, the non-changing element there is that the concept remains constant. And like before, okay, new experiment, done in a different way, a new data set. So remember, the key thing to remember here, conceptual replication, subjects, methods, designs can change. Direct replication, subjects, designs, and methods do not change. Okay, but both of them produce new data sets. Okay, how do we control for external validity? How do we try to bolster and strengthen the amount of external validity that we have, right? So we can use many of those same tools, right, for internal validity, and there's often a relationship. So a key element that we can utilize to try to increase our level of external validity is randomization, right? And so ultimately, here's the key: randomization, right? Just like the fact that it actually increases the heterogeneity of our sample, right, and minimizes and neutralizes the effect of not only obviously bias, but neutralizes within group differences, right, and assumes that groups are equal. Randomization does the same thing for external validity because it replicates the heterogeneity and diversity inside of a society. Okay, that's why randomization is important. So some designs that we attempt to utilize to control for external validity, obviously pre-test, post-test designs, static group comparisons, right? I know you guys have particularly started talking with Claire about t-tests in the stats portion of the class, right? But one of the big ones that we're going to get into later on in the semester is quasi-experimental designs. Okay, that has been a very salient answer, right, to threats to external validity. So there really are four main threats to external validity that we're going to learn about, right? And so that's the interactive effects of testing, selection bias, experimental effects, and then multiple treatment interference. Okay, so interactive effects of testing. Okay, here's the deal. Okay, this is a lot like a testing effect or a practice effect within our internal validity. Um, so ultimately, this is the presence of a pretest that makes the participant more sensitive to the treatment, okay, and thereby artificially inflating the result, right? So if we expose, um, potentially a participant to some sort of baseline test that has an element of the treatment in it, right, we may actually inflate the impact of the treatment on the outcome, right? And so that can have a direct effect on our external validity. This is analogous to a testing effect or a practice effect with internal validity, right? Selection bias. Okay, so this is non-randomization of participants. Okay, this is selection of participants based on specific criteria. Okay, and we don't randomize or assign to groups, and that might actually produce a result um, that's not generalizable to the population, right, as a whole, because we are essentially, um, you know, getting a result, right, from a population that was selected based on a certain characteristic, right? An application of those findings to the population as a whole does not match with the heterogeneity of society and the assumed differences between people um, within that specific variable of interest. Okay, experimental effects. Ultimately, this is plain and simple, right? Treatments or experiments performed in a laboratory have limited practical application in the real world, right? And so we talked about obviously true, true experiments, and then those conducted on animals, obviously cannot be readily applied to humans. Multiple treatment interference. Okay, so this is where, for example, we introduce too many confounding factors, right? Maybe we have too many levels of the independent variable or too many things that we do within a study, and we don't adequately control or define our independent variables, right? And so if we don't adequately control or define the independent variable and how that's applied, right, those multiple levels of the independent variable or multiple treatments can actually uh, dampen our statistical analysis and actually weaken the impact of the independent variable, rather, excuse me, on the dependent variable. Okay, that's called multiple treatment interference. Okay, so here's the thing. Okay, we've talked about obviously that experimental designs, guys. Obviously, there's a lot about these that are ideal, particularly if our study has a high level of internal validity and external validity, which is very hard to achieve, right? It can be done, but it's obviously not always practical. So a lot of times, certain designs attempt to really heighten the level of external validity, but often, right, they will lack an important, component of internal validity, such as randomization, blinding, so on and so forth, right? Obviously, that can affect the overall validity and reliability of the results because it makes the study itself not easily replicable, um, and can introduce confounding factors. Okay, so obviously, we can achieve an ideal balance between internal and external validity, but we have to obviously pay attention to randomization, the setting, right? Because we know that research conducted in a controlled setting will typically not generalize well to the population, right? And then obviously clearly define our inclusion